This week we will cover relationships between variables. Statistical techniques last week. I would like to review some major concepts. First, what kinds of questions can we answer with statistical technique? Basically, we can answer two kinds of questions. Are variables related? Are groups different? In other words, statistical techniques are used for describing and finding relationships among variables, also detecting differences among groups. What are the two aspects of statistics? The answers are effects reliable? Are relationships or difference of practical significance? Correlation is a statistical technique that allows us to measure and describe a relationship between two variables. So the correlational techniques are typically used to analyze relationship-type research. With correlations, there will gonna be two variables. They will be observed, measured, but they will not be controlled or manipulated. We all have to have two individual scores, all from the same individual. So everybody in my population or sample has to be tested on variable X. Also everybody has to be tested on variable Y. I am going to have a score X, Y for each individual. Oftentimes we use a scatter plot. Plot is a graphic representation where I plot the X score against the Y score. This is very similar to plot a X value and Y value back to high school math class. But it allows me to identify the visual representation of relationship between two variables or two sets of scores. Now we are talking about correlations. We are talking about the scat plot describing the relationships between variables. When we are talking about the correlations, we usually focus on three characteristics of the relationship between the variables. 1. Direction of the relationship. 2. Form of the relationship. 3. Degree of the relationship. We will cover these characteristics in the following slides. I measured two sets of score, so when we are talking about the direction of the relationship, we are really talking about identifying the sign of the correlation coefficient. Just like inferential statistics would do, examining the relationship studies, you will use correlation statistics, and you calculate correlation coefficients. Correlation coefficient generally ranges from -1 to 1. R can be a positive value. When it is a positive value, it means the variables tend to move in the same direction. For example, if I am taking the temperature outside, and the sales of ice cream, I measured two sets of scores, and looked to see how the variables varied. What I am going to find out is when the temperature goes up, the sales of ice cream increase, when the temperature goes down, the sales of ice cream decrease. So that would be an example of positive correlation. A negative correlation is the variables tend to move in opposite directions. For instance, we will use temperature and the sales of heaters as example here. In other words, when the temperature goes down, the sales of heaters increase. On the other side, when the temperature goes up, the sales of heaters decrease. Shows two scat plots for both positive correlation and negative correlation. Basically, if I had to draw a line through a scat plot, I am trying to determine which direction a line would go. On the left, the scat plot shows positive correlation, while the scat plot on the right demonstrates the negative correlation. Here, correlations also tell us about the forms of the relationship. These relationships can be linear, or curvilinear. If it is curvilinear, then it is not gonna fall in a line. If it is linear, then it will fall in a line. The stronger the relationship is, the higher our value is, and the more linear relationship is. Correlations are also going to identify the degree of relationship. In other words, How closely do the scat plots fall somewhat into a straight line? The stronger the relationship is, the more straight line it gonna fall. Basically, this particular example, if you look at the illustration at the far right, which is perfect high, you have the scat plot. Basically, all those points lie out on this straight line. The correlations fall within a range of -1 to +1. This particular example would be correlation with AR value close to -1, because when one variable increase, the other variable decrease. If the line went with the opposite direction, then the R value will be +1. On the example of far left, it is moderate value. It again shows negative relationship. The R value is probably somewhere around -0.5 to -0.6. In the middle illustration, there is really not a straight line at all. It looks like a circle. That means low relationship or no relationship. So the R value will be near 0.